Hey there, Math 1, 12 students answering a question from the discussion board. Somebody's asking about this question, which is Winter 2019, problem 4b. Please let me know if this helps or if your question was about some other part of this. I do have a collection of videos that's about, this would appear on page 3 of our final. And I have a video where I did several of these sorts of questions, and then I also talked about consumer supplier surplus. So that involves these skills. And I think I did this during one of my review sessions, maybe the Zoom review, maybe the in-class review, I can't remember. But I have no problem, let's do it again. So what are we trying to do? So just a reminder, this is more than you need. Draw this little picture down here. We have this tool that will find the area. And this is just a discussion here. This is not part of this problem. So just hang with me for a moment. If you want the area between two graphs, what we do is we find the area under the top graph, we find the area under the bottom graph, and we subtract. That's the whole strategy of how we find the area between two things, because we have a way to do this, right? If this is the top function, we can do the integral from 1 to 4 of f of x dx. And this one we can do the integral from 1 to 4 of whatever the other function is, the bottom function. And then we subtract. That's it. That was really the idea of the section. And then we said, okay, let's use it. Meaning, what do you need to make that work? Well, you need to know what's on top. Well, that's right here. You need to know what's on bottom. That's right here. You need to know where you start. That's right here. So this is the start. And you need to know where you end. So that's the only thing they didn't tell us. So when we write this question, we would do the integral from 1 to something. We're going to have to figure that part out. Of top minus bottom. Now I would write it was 1/2 x because I know I'm about to do some calculus. That's what we were talking about when we were doing that back in section 13.3 and 13.4, where we did several of these problems. So we need to be ready for that, but hopefully you know how those pieces go. So the only thing left to do is to figure out what this is and then compute. So if you don't know how to do the intersection, let's talk about that for a second, if that's what the question's about. So we need to know when the following two things intersect. And honestly, we probably could guess it, but let's say we couldn't guess it. You combine, you substitute one in for the other. And so then you would get the square root of x equals 1/2 x. I feel like I want to multiply both sides by 2. That's not actually necessary. And now we have this problem. How do you solve that? Now you can make this harder or easier on yourself, but you solve that by getting rid of the radical. You square both sides, and that gives you 4x equals x squared. And then we need the solution. You can divide both sides by x. You can move everything to the same side and factor. Maybe we should do that. Move everything to the same side. There's many ways to get this. So I feel bad showing any particular way because people are going to be like, I wouldn't have known to do that. We just need to make progress here. You could use the quadratic formula now. I personally would factor. And I would see that the solutions are 0 and 4. So this needs to be 4. And then I would double check it. When I plug in a 4, do these things give me the same value? That's where I end. We talked about this in class. I'm just taking a little time here because I suspect that could be one of the questions. We talked about how no matter where we are, we're between the same top and bottom, and we would like the area between 1 and 4 for those two things. Okay, from here on out, it's computation. So we prepare to do calculus, which means we write this as x to the 1/2 minus 1/2 x. We integrate. So remember, this is a definite integral. This is what we did in 13.2 with 13.3 and 13.4. So we add 1. This becomes 3/4. We flip it out in front. This becomes 1/4 x squared. So the power went up 1. I divided. And now we're going to plug in a 1 and a 4. So the rest of the problem is computational. So do let me know where your question is on this, because I'm kind of guessing where it is. I'm suspecting it either has to do with not knowing how to find that number or a calculation mistake. So let's talk about the calculation here for a second. If this does help you, also let me know that, because sometimes I never know if this was worthwhile for me to make, but I hope it was. And my hope is it helps other people who are stuck on this. Okay, so what do we get now? Let's compute. Now, 4 to the 3 halves, I always jokingly say in class whenever something like this comes up, impress your friends. You actually know what that is. I say, how would I know what that is? Well, 1/2 power is square root. So this means square root and then cubed. Square root of 4 is 2. 2 cubed is 8. So actually you can do that in your head if you think about what it means. Minus, this is going to be 16 over 4, which is 4. You can see how I like to just simplify what I can simplify before I worry about grabbing my calculator. So anyways, from there on out, it's a straight calculation. So this is going to be 16 thirds minus 4 minus 2 thirds plus a fourth, because I distributed that negative. And what is that all together? 14 thirds minus 4. I just put the fractions together. At that point, if you wanted to go to a calculator, you could pull a calculator out and do your quick calculation. So I don't want to make you think you have to keep going with with all the fractions and stuff. So I do think it's nice to simplify a little bit as you go. 14 over 3 minus 4 plus 1/4. Okay, I got 0.916. It's a little harder to check your work on these ones, but you could see if it's like reasonable, meaning you could label these points. I think when I plug in a 4, I get a 2. When I plug in a 1 here, I get a 1/2. When I plug in a 1 here, I get a 1. You can find the area of this triangle, and it should be pretty close to that. Well, I guess that triangle's not the easiest to measure, but you can get the idea. I mean, whatever this area is, you could estimate, is 1 reasonable? Well, it goes 3 this way, and it goes a pretty small amount, not 3. It goes, 3 that way. It goes just a very sliver the other way. Is that reasonable? Let's check the solutions and see. Can I pull this up quickly? Yes. See if we got something reasonable. The scale of my graph, I think, is partially what. Okay. 11/12. It's actually a smaller sliver probably than my picture makes it look. There we go. Let me know if that helps. Move on.